Okay, so good day. In this video, we will be continuing the second installment of our second series of discussion for this subject AC43. So we already finished Unit 2 or the compound amount. Now we will be talking about the present value and equivalent values. Now let's start with the present value. I believe we have already discussed this in our Unit 2. So if I may just guide you back, no, in our Unit 2 we have discussed, no, how to solve for problems when the present value is unknown and the compound amount is known. So this is this one. So this is this part. So just a simple recall, no, on the formula of for present value. So that's A is equal to this is the formula for the compound amount. So A is 1 plus I num over M raised to the power of mt, or A is equal to P times 1 plus I raised to the power of N. And then to solve for P, since P is our unknown, so we reverse the formula para nasa left side si P, and then by transferring the 1 plus I raised to the power of N expression to the right side, we then eliminate it from the left side and then transform into division iyang operation. So the new formula would be P times I is equal to A all over 1 plus I raised to the power of N. But if you want the multiplication imong gamiton, we can change that into multiplication by changing the operation or the sign of your exponent from a positive sign to a negative sign. So we can also write the formula as present value is equal to compound amount or future value multiplied by 1 plus I raised to the power of negative N. Okay, so just to give us a little bit of recall before we go to our fractional period of time, let's just assume for this, let's just think muna put things or sa man gyud ay ang present value, sir, no? So there are instances, guys, no, for example, as a person, you have a goal nga tawag nito nga nakay-kwarta by the end of 5 years nga 100,000. So, pila man ang imuhang i-deposit karon para manganak siya nga manganak nga at the end of 5 years, ang iyahang final amount would be 100,000. So, the 100,000 down is your goal, which is your compound amount na goal or your future value na goal. And then your question now is, pila man ang imuhang i-deposit karon para mo go siya towards that amount. Okay? So, for example, no? So, kato example, you are planning to buy a land worth 100,000 5 years from now. Ooh. 5 years from now. Assume that you can invest your money in the bank where interest is computed at 9% compounded quarterly. How much should you deposit today? Okay, so this is the question. So you are planning to buy land worth 100,000 5 years from now. Assume that you can invest your money in a bank where interest is compounded at 9% compounded quarterly. How much should you deposit today? So we now have our compound amount or target amount of how much? 100,000. We now have our INOM, which is 9%. And then our T is 5 years. Now, our M is quarterly, so we have 4. So that should give us an I. That should give us an I of 9% divided by 4. And a term, let's just express this into percentage. Total term, total number of compounding periods of that's 5 times 4. So, in solving for our present value, no, again, we can solve it by dividing the compound amount. So, that's 100,000 divided by 1 plus our I is 0.025, and we raise that to our total n, which is 20. So this is n. Our present value, or the money that we should deposit today for it to grow to 100,000 in 5 years with an interest of 9% compounded quarterly, is 64,081.65 pesos. Or you may also solve it this way. P can also be also solved as 100,000, and then we multiply that by 1 plus our I, and we raise that to our negative n. That should give you the same amount. Okay. So that's how you solve, or that's the reason why we have to solve for the present value. Okay, and then that's how you solve the present value in 2 different ways. Another thing, if you don't want to compute for I and n and make use of I, num, m, and t, then you can also do that. So this is the third way. So that's let's just use the multiplication, no, the second one, with the negative n. So that's compound amount of 100,000, and then we multiply that by 1 plus our I is 0.09 over our m, which is 4, and we raise that to negative t is 5 multiplied by 4, which is our m. That should give you the same amount. Again, it was solved as the a, or compound amount, multiplied by 1 plus our I, num, over m. We raise that to negative t times m. Okay, so with that, let's see here. I hope that you can recall now that in Unit 2, we also discussed how to compute for the compound amount if there is a fractional period of time. So, fractional part of compounding periods. Diba? Remember, for our Unit 2, for computing the compound amount, with fractional time, what you have to do is you have to get the whole na, what do you call this one? Whole na m, or whole na total compounding periods, and then from that whole, you get the compound amount using that whole amount, and then you then compute for the simple interest of the compound amount computed initially for the remaining fractional time. So for example, 3 years and 2 months. So for the you compute first for compounded semi-annually. You compute first for the future amount for 6 periods. That's 3 years times 2 because it's semi-annual. So that's for 6 periods. And then you compute for the simple interest of that compound amount for 2 months, for the remaining 2 months. On the other hand, for our present value with fractional period of time, let's just move it downwards. Fractional part of compounding period. Okay, so fractional part of compounding period. So, in this case naman, no, sa fractional part of compounding period, it's different in a way na kasi kanina for unit 2, you rounded it down in a way, 'di ba? Kasi kinuha mo lang yung whole number. For the fractional part of compounding period na present value, you round up. By round up means you get the whole amount of the compounding periods, and then you add 1. So for example, in this case, find the present value of a non-interest bearing note of 10% for 3 years and 2 months at 6% compounded semi-annually. So semi-annually, do not be what do you call this one? Do not be fooled by the term non-interest bearing note. Okay, so So find the present value of a non-interest bearing note of 10,000 for 3 years and 2 months at 6% compounded semi-annually. So here, our N is again M times T. So our M here is semi-annual man siya, no? So our M here is 2. And then, what is this? Ah, yeah. Okay. So, we can solve it this way, no? Or we can solve it by doing this. How many years? How many months are there? 3 years times 12. So, 3 years times 12 months plus 2, right? Yeah. Divided by 6 months per semi-annual. So, that should give you a total compounding period of 6.33. So, there is a what do you call this one? A fractional part of a compounding period. If we were solving for the future value, we would round this off, get 6, and then just compute for the remaining 2 months, 2 over 12. 2 over 12. However, if we will be computing for the present value, what we should do is round it up. So we will be considering 7, and then we should what do you call this one? Deduct from we should add from our resulting value the interest for the excess months we turn back in a way. Okay. So for example, how many months is 7 years? 7 years. How many months is 7 semi-annuals? So 7 semi-annuals is 7 times 6. That's a total of 42 months. How many months lang dapat imuhang gibalikan? So that's 3 years times 12 plus 2. That's 38 months lang dapat. So you have an excess of how much? 4 months. So you add from your present value you computed using 7 periods, 4 months of simple interest. Okay, so sorry. Okay, so we can also represent this counting of number of months, no, or number of semi-annuals in a timeline. So what is a timeline? So this is what you call a timeline, no? So it's a line divided into different periods of time. That's why it's called a timeline. So, diba, we were told that our non-interest bearing note will have a maturity value or a compound amount or a future value of 10,000 pesos. So that is our expected value 3 years and 2 months from the date of the note. So what we are trying to compute for here is how much is the value of the note at year 0. Okay? So since diba, we will be going back 3 years and 6 months backwards. So that's 3 years and 6 months backwards. So from 3 years, let's just add another line here. Sorry. Well, let me just extend this na lang. Border. Para makita ninyo siya. Okay. So 3 years and 2 months here. And then 6 months downwards. Oh, just move my face. Okay. So, what happened here? Okay. So 3 years and 2 months. So 6 months downwards, we'll have what period? That's... we have to move 7... Okay. We have to move 7 times backward. So, first movement na to would be... The remaining time would be 2 years. 2 years and how much is that? 8 months. 2 years and 8 months. So how did you get that? Okay, so 3 years and 2 months, that's so minus 2 months, 3 years lang mabilin, and of the 6 months yung minus 4 months ang nabilin, 12 minus 4, that's 8 months. So The second time that we would move, okay. Second time that we would move, so 2 years and 8 months minus 6, that will give you 2 years and 2 months. So another one. This is our third na movement backwards. So 2 years and 2 months minus 6 months, that should give you 1 year and 8 months. 1 year. Okay, and then another 6 months backwards. That should give you 1 year and 2 months. Again, and then the fifth movement backwards. Okay, fifth movement backwards, that should give you 8 months na lang nabilin. And then, sixth movement backwards. 2 months ang nabilin. And then, narin kay in between year 0. So 2 months minus 6 months, that's how many months? That's negative 4 months. Okay. So meaning, you have moved backward 4 months more than you should have had. Okay. So let's solve first for our present value using 7 periods, 7 compounding periods. So that should give us 10,000. And then we multiply that by 1 plus. Our I here is 6% compounded semi-annually. So that's 0.03. That's 0.06 over 2. And then we raised that to, again, 7 periods. So negative 7. Since I am using here the multiplication operation, I'll be using the negative sign for my numerator, for my exponent. Okay, so that should give us 8130.92. So that's our present value 4 months earlier than the start of the note. So what we should do is we should compute now for the interest, for the simple interest for the excess months that we backtrack. So pila ka months to 4 months. So simple interest lang ta. So simple interest, di ba? Simple interest formula is simply PRT. So our simple interest here would be the 8,000, the present value. You multiply that by the R. So our rate here is 0.06. Sir, ganun wala na to siya gihimong 0.03 nga sa may annual man. Now remember, for simple interest formula, we are expressing terms annually. Okay, kay simple interest man siya. Dili man siya compounding na dayon. Nag-compounding ta for 7 periods, and then after we solve using the compound amount formula, we then use the simple interest formula for the fractional time. This time, katong excess nga ni-atras ta. Unlike sa unit 2, na ang nabilin na should be period. Okay, kani, what we are solving for is the interest for the number of months nga nasubra ta og atras. So 0.6 times, how many months did we exceed? 4 months over 12. So this is now your simple interest. So that means that your compound amount at year 0 should be 8130.92 plus 162.92, 8293.53. Okay. So this should be your final answer. So this should be the amount that you should deposit today. So it would accumulate to 10,000 pesos 3 years and 2 months from now. Okay. You may also solve it using this formula, no? This one. This is the parang one-time solving version. So one-time solving, no? So first, if you what do you call this one? If you look at this formula, no? This first expression, I'm gonna highlight it na lang. This one represents your compound amount at katong present value din mo nga formula na rounded up ang imuhang n. And then this one represents the simple interest for the excess months or excess nga period or excess nga days nga imong nasubrahan og atras. So, sir, how do we solve that? How would that look like in our calculators or in our Excels? So, our compound amount is 10,000. We multiply that by 1 plus, so 1 plus our item is 0.06 over 2, or you can just simply use 3 here, 0.03, since we know that already. We raise that to, how much is our rounded up na compounding periods? That's -7. And then, after that, we multiply it with 1 plus our annual rate, so our item 0.06, and then we multiply that by katong excess months 4 over 12. So, sir, kanong ayun ko, sir, simple interest ng formula nga nung may 1 plus. Okay. Remember, in solving for the compound amount formula using simple interest, we use parang future value is equal to principal times 1 plus RT. So our principal here would be the present value of your compound amount using a rounded up na compounding periods. So that should give you the same answer. Sir, sorry. HVR. Sir, what if nasayop ni sir nga instead of just rounding it up to 7 compounding periods, we rounded it up to 8? Would we still arrive at the same answer? Unfortunately, no. Kay what will happen is that naagyo discrepancy between compounding period and simple interest. Labi nagmulabay na siya og 1 compounding period. If you mistakenly went back in excess of the number of months that you should go back. No? So for example, you went back another one. So you went back another period, another compounding period. So meaning, emong excess na dayon, this would be negative 10 months, right? 10 months. Ay. Negative 10 months. Okay. So, sa imong negative 10 months, nakalabay na kag 1 compounding period na 6 months. So, this will not give you the same answer. So, let's just, for illustration purposes, let's solve it. So, that's you, parang 8 lower imong pagka-solve. So, let's just copy this formula. This one. Okay. Let's copy this 2. And this 3 na lang din. Okay, just move my face for a while. So this, I will label this one as mistakenly went back too far. Okay, so here, what if we used 8 here? So your excess would be your excess months would not just be 4 months but 10 months. Okay, so again, this will not give you the same answer because sa imuhang compounding period, no, you eliminated an interest ng anak na supposedly. Kay this one, the simple interest for the 10 months, missed the anak of the anak. That's why it's lesser than that should have been answered that you should have arrived at. So that is why you have to be careful. You have to do it this way, no? Na if it's number of days, express the entire term in a number of days, or if it's number of months, express it in the number of months and divide it by the number of months per compounding period to be safe. Para dali na ka mag-round up. Okay? Basta ibigin ka na 3 years and 2 months. Sige sir, I will round it up diretso to, what do you call this one? I will round it up diretso to 4 years. So that's an excess, diba? Kay a complete compounding period would have been enough if 3 years and 6 months lang imong gigamit. Or what if the term was quarterly? So quarterly, 3 years and 2 months quarterly. So and you mistakenly used 3 years and 6 months. Na 3 years and 3 months would have been enough already. So you have to be careful in rounding up your um, compounding periods. Okay. So with that, we're done with our fractional part of a compounding period. Let's go to equivalent values. So for equivalent values, no, it's just simply it embodies, it embodies the concept of the time value of money. Na your 1 peso today will be equivalent to an amount in the future na nanay anak. So, your present value today is actually equal to your future value, uh, not because kanang tawag ani because they have the same amount, no, because as we have said, no, future value is always greater than the present value. They are equal, or they are not equal, but they are equivalent values, because your present value becomes your future value when a time would pass, and your future value becomes your present value if we went back on time. Okay, so for example, no, let's take this first example. A debt of 20,000 is due at the end of 4 years. If money is worth 6% compounded quarterly, what is the value of the debt when it is paid at the end of the year, or at the end of 6 years? Okay. So, okay. So this is your timeline. You have to plot first your timeline para dili ka malibog kung what do you call this one, whether you will be solving for the present value or whether or not you'll be solving for a future value. So in the given problem, a debt is worth 20,000 pesos 4 years from now. So 4 years from now, no? So we are at year zero. Put yourselves in year zero and imagine that 4 years from now, your utang will be worth 20,000 pesos. But what if you would choose to, assuming no, walay penalties for early payment, things like that. Assuming na instead of paying it 4 years from now, how much should you pay 1 year from now na would still extinguish the debt? Diba? That would still render it paid even if you will not pay 20,000 pesos. So meaning how much would you save on interest? Okay, if you would pay it, diba? If you would pay it earlier, dili na ka need magpay sa katong interest for the remaining 3 years or remaining 2 years, diba? 3 years, 3 years, remaining 3 years. Okay, from 4 years, you will be paying na lang man, you will be paying man 3 years earlier. So, so how much more, but how much interest would you save in a way if we're paying early? So, again, our base year is year 4, and then first is how much the puno would you pay if you pay earlier by 3 years. How did we compute for the 3 years? Diba? You will be 4 years from now ang katong situation, and then you are asked na how much should you pay if you pay the debt 1 year from now, not 4 years from now. So at year 1, the value is unknown. This is unknown. It was just solved na diretso, no? But this is unknown. This should have been unknown pauna, but I'll be showing you later on how I solved for that. And then this is your 4 years from now na value. So 20,000. So since 1 year from now man nga value ang gipangutanan, no? How much should you solve it? How should you solve it? So first is you have to determine whether or not you will be using the present value formula or the future value formula. If you went back on time, then meaning you will be using present value. If you have to go further in the future, then that means you have to use future value. So again, no, in your timeline, guys, the amount on the left is a present value. The amount on the right is a future value. So, for example, here, we know for a fact that the value of the debt 4 years from now is 20,000. But we do not know how much it is worth 1 year from now. So this is your unknown. So your unknown is on the left side. So PV is unknown, FV is given. This means you should be using the present value formula in solving for this problem. So in this problem, we already know that our future amount is 20,000, 6% compounded quarterly. So that's 0.06 over 4. And we will, how many years did we went back on time? That's 4 years minus 1. That's 3 years. Okay. So, formula would be PV. Number of years backwards. That's 3 years. Yeah, 3 years. So M is 4. Our item is 6%. 6%. So that should give us our total N would be 3 times 4. That's 12. Negative 12 to be exact because we went back on time. And then our I should be at 6% over 4. So 1.5%. Okay, so that means that our PV here should be at 20,000. We multiply that by 1 plus our I. And then we raise that to negative N. We use the negative sign because we are solving for the present value. 16727.75. Okay. Now for the second problem, what if the kuno, instead of paying it on the 4th year, you have i-delay imong payment to the 6th year. So meaning you will be paying more interest, diba? So in this case, we know for a fact how much is the debt worth 4 years from now, but we don't know how much it is worth for an additional of 2 years. So meaning here, our PV is known, but our future value is unknown. So in this case, we will be using as our formula, need to add more column rows. Okay. So our formula here should be a future value formula. Number of years forward, 2 years, that's 6 minus 4. So 6 minus 4. How many years? So 4 minus 1. Or 1 minus 4 na lang. Para makita nyo yung negative siya. 1 minus 4. Oh my God. So, yun ako mag-negative. Kaya naka-negative naman siya. Okay. So, ayun. Number of years forward, 2. Our M is 4. Our INM is 6%. So, that should give us an I of the same. Now, 1.5. And then, our N here would be 4 times, number of years times 4. So, 8 periods. Okay. So here, since our future value is unknown, we can now solve for our future value. This should, using the future value formula. So, present value of 20,000. You multiply that by 1 plus 0.0 plus this one. And then we raise that to our positive this one. That should give us 22,529.85. Sir, how come, sir, diba? Si 20,000, sir, kay future value man na. Ano na present value naman na siya karon, sir? So, if you can recall our discussions, I don't know if it was in the Unit 1 or Unit 2, no? Na with the concept of the time value of money, your future value can become a present value depending on which perspective you are looking at. Okay? So, in the first scenario, no, future value yun siya. Kaya siya man ang value ahead. What we were looking for is the value man before that particular period of time. So, siya ang future value atong nga time, and then anong si present value. On the second scenario naman, we were looking for a value further in the future. So, katong further in the future is now your future value, while your 20,000 now becomes your present value. Okay? So, ayun. So, that's the first example for equivalent values. Tama naman, no? We were done with fractional time, equivalent values, and then, yeah, okay. So, for our second example for equivalent values, no? So, Jude owes money. I can just delete this na lang siguro because it's already discussed there naman. It's just how I solved for the kanang how much did we go backwards, or how much did we go, or how long did we go forwards. Okay. So Jude owes 3,000 due in 3 years and 40,000 due in 8 years. Okay. He and his creditor have agreed to settle the debts by 2 equal payments in 5 and 6 years respectively. Find the size of each payment if money is worth 6% compounded semi-annually. So now we have two different types of money. Okay, one group is a liability. The second group is a payment. So payment is used to extinguish a liability. So we have to solve for values at different time periods wherein payment is equal to liability. And how saan mo na siya, sir, no? So this is how you do it. So we draw a timeline again. So we know for a fact that there is a debt. So let's just label it as debt. So debt 1, our liability 1, is 30,000 due in 3 years. So we know na this is the value at year 3. And then we have a second debt of 40,000 due in 8 years. So we have debt 2, which is our both the debts are known values. What we don't know now is how much should the first and the second payments be when the payments are made at two different different periods, which are totally different then from the maturity dates of the original debts. So this is payment 1 and this is payment 2, because as they have as indicated, no, payments for the debts will be made on years 5 and 6. So payment 1 and payment 2, these factors are unknown. Okay, so for this one is either for this timeline, no, we have two different unknown figures. What you should do now is you should choose which perspective you will be focusing on. Is it on year 5 or is it on year 6? Either way, we will be arriving at the same answer. So first, let's focus na lang muna on okay. So I assume what is this? Okay, no. So what do you call this one? Let's assume muna on the point of view of perspective is at year 5. Perspective is at year 5. So if our perspective now is at year 5, we have to know the values of debts 1, payment 1, payment 2, and debt 2 at year 5. So here for debt 1, diba? This will be a present value, and this will be a present value, this will be a future value. So you want to translate your present value of 30,000 to a future value at year 5. Okay? So because we have to express these values towards year what do you call this one? Year 5. Okay? So, and payments, by the way, are equal. So, AA. Right, AA. Okay, payment 1 and payment 2, they're equal amounts, man. Okay, so, for your debt 1, the future value of your 30,000 compounded semi-annually at 6%. For how many years would you go forward? We have to go forward by two years. Okay? So, or if you want, pwede na po na to ni siya nga ihimay-himay yun, no? Para like very clear and everything. So, formula na to would be, again, future value, years forward, we have 2 years forward, and then our I is more of like a sige na lang, I nom is 6%. That should give us an I of wala pa man tayo end I. Our term, term, so our M is semi-annually, so that's 2. So that should give us an I of 6% over 2, 3%, and an N of 2 times 2, that's 4. So our future value at year 5, let's just, okay, para mo tunong siya sa year 5 ang future value. Okay, so our future value of our 30,000 in year 5 would be 30,000. We multiply that by 1 plus our I of 0.03, and we raise that to our N of 4. So 33,765.26. For our payment 1, it's still at A because diba, our focus period is year 5. So A. A lang. Wala man ka nag-move. So wala kay additional, wala kay deduction. For payment 2 naman, no? For payment 2, let's just payment 2. Okay. So for our payment 2, this is our PV and this is our FV. Okay? So we know that the future figure of this payment 2 is A. Okay? But we don't know how much it is at year 5. So known ang year 6 but unknown ang year 5. So what happened? We went backwards, meaning we should use our formula present value. So years backwards, that's 6 minus 5 or 5 minus 6 para negative yun siya. So that's negative 1. Our I name is 6%. M is still at 2. Okay, so N is negative 2 now. Negative 1 times our M of 2. Same I. So our PV now would be A times 1 plus 0.03, and then we raise that to what? We raised that to negative 2. Okay. Sige, we raised that to negative 2. Next. Okay. And then this will actually give us how unsang figure sa A, no? That's 1 plus 0.03. How much is it? 1 plus 0.03. We raise that to negative 2. Okay. So our parang new value of A would be A, and this one. This one. Okay. So this is our accompany dapat dili si A sa last siya. Sorry. Okay, this is assuming no, we don't round off during the process, which is the very kanang ideal thing. Round off ka lang at the pag na final answer para wala kay discrepancies na kayo. Okay, so this is now the equivalent value of 1A just two compounding periods before. Okay, so that's 0.948. For our debt to, no, or that too. So we know that our future value is 40,000. What is unknown is the value at 5 years at the fifth year. So that's like going backwards. So that means we have to solve for the present value. So how many? So formula is present value, and how many years did we go back? So 5 minus 8. That's 3 years. So that should still give you um, an I of 0.03 and an N now of -6. So our present value of 40,000 would be 40,000 multiplied by 1 plus 0.03, and we raise that to our -6. Okay, 3499.37. So as what I have said kanina, no, to equate our let me just delete this two na lang. This one. Which is match. 11. Let me just, I don't know. Wait lang, hide this na lang. Sorry. Okay, there. Okay. So as what I have said kanina, no, at year 5, since we have already translated, kaya diba, at this time, at figures at years 3, 5, 6, 8, without translating them into their equivalent values to year 5, it's like we're comparing an orange to an apple, to a banana, to a guava. Diba? But by translating them into their equivalent values at a specific period of time wherein same sila, so that's on year 5. So we are trying to translate them into into an item nga from we're translating the orange to become an apple, the banana to become an apple, the guava to become an apple. So we can compare we can compare all of them. So, 'di ba? So again, what we're trying to solve here is um, looking for the payment, no, that will extinguish the debt. Okay. So in this case, since we are looking for payments that will extinguish the debt, it should mean that the equivalent values of all payments should be equal to the equivalent values of all liabilities. So for our payments, for our total payments, no, they have it's not A, but A plus A, right? Kay we have, kay equal man sila. A is equal to B man, so A plus A. But when, this first A is our payment on year 5. The second A is our payment on, year 6, but translated to year 5. So, balik ta og two compounding periods kasi man alol mo to siya. So, that's A can also be read as 1A, well, 0.94A. So 1A plus 1 plus 0.94 is 1.94A. And then your total liabilities, your first liability translated to year 5 from year 3 is now at 33,765.26 as what we have here. And your liability of 40K on year 8 translated to year 5 is now at 33,499.37. So that's a total of 67. No? And then now our payments, so our A now, both payments on years 5 and 6 would be computed by dividing this number by the this 1.94 here, the number beside A. So that's our accompanying sorry, our parang accompanying value ni A here would be this one, the 0.94 plus the 1 ni A, katong original payment, the payment at year 5 plus 1.94. So if we divide this figure, the total of the debts by this numerical value nga kauban ni A, we will have 3466.16. So that's our payments both for year 5 and year 6. So how do we check for it, no? So payment on year 5 plus our payment on years plus our payment, no, which is equal naman din payment on year 6, which is the same amount. We multiply that by the 1 plus 0.03 raised to the power of negative 2. Diba? 1.06 over 2 is 0.03. 2 times negative 1 is negative 2. So 1.03 raised to the power of negative 2. That should give us this amount. And if we add that, if you add the 2, this should give us the same amount of our liabilities. Okay? So, ayun. So, ganon. Like this one minus this one, this should give us 0. Okay. So, our final answer then would be this one. So, sir, what if I choose to parang use as my perspective year 6? O sige, let's use as our perspective year 6. Let's just delete this. Okay, let's use as our perspective year 6. Okay, year 6. So if we translate things to year 6, di na nakulit ni ingan niyo ta sa tags, no? Like paano ta more direct way. More on like kinaspasa in a way. Okay, so now we are translating 30,000 to as equivalent to its equivalent value on year 6. So that's 3 years forward, and we are semi-annual, so that will give us 6 compounding periods. So that's 30,000. Since we're going forward, no, so future value times 1 plus 0.03, we raise that to 6 compounding periods forward. So this is our equivalent value for the accompanying so for B, for liability B, let's just give it a value of 1. Okay, di ba? 1B or 1A. 1B, 1A. Okay, so that's for the second payment. For the first payment, no, we are going forward to year 6, from year 5 to year 6. So this should give us a future value of 1 times 1 plus 0.03. We raise that to what? Forward man, 2 periods. Okay, raised to the power of 2. Ay, okay. Equals. Okay, and then for our 40,000, we have to go backwards from 8 years from year 8 to year 6. So that should give us 40,000 times 1.03. We raise that to negative 2 years. 2 times 2, that's 4 years. Okay, 4 years, 4 compounding periods. So meaning our accompanying value for A would now be for our payments would now be at 1.1609 plus 1, that's 2.609, and our equivalent value of our liabilities would be 35 plus 35, a total of 71. So now our payment should be at 71 divided by this one, 3466.16, which is the same as what we have gotten here. So if we deduct this from this, it should give us 0. So no matter which time period you would be looking at, you will still arrive at the same answer. The reason for that is because we are using, or we are calculating using their equivalent values. So we are now comparing apples to apples. Okay. So next, so Jake owes 70,000 due in 3 years and 100,000 due in 8 years. His creditor has agreed for him to pay the debts with a payment of 80,000 in 1 year and the remaining in 5 years. If money is worth 4,000 compounded annually, what size must be the second payment? Okay, so we have here a row for payments and a row for liabilities. So our time periods na kung ano, we have year 3 and year 8 for liabilities at 70,000 and 100,000 respectively. We also have year 1 and year 5 for our payments with 80,000 for year 1 and an unknown value for year 5. So now since the year 5 is sa year 5 atong unknown value, we have to translate our known values, which are debts 1 and 2 and payment 1 to their equivalent values to year 5. So for payment 1 is 80,000 times 1.04 for 4% compounded annually. Diba? So 4 raised to the power of how many years forward? That's 5 minus 1. That's 4. So that should give us 93,588.67 for our first debt. That's 70,000 and we have to go forward by 2 years. So 2 compounding periods since annually naman siya. So 70,000 times 1.04 raised to the power of 2. That should give us 75,712. While for our debt 2, from year 8, we have to go backwards to year 5. So we are trying to solve for the present value here. So 100,000 times 1.04 raised to the power of the number of years that we went back. That's 5 minus 8. That's negative 3. Okay. So using our formula na total debts, total payments is equal to total debts. So our total debts would be 75,712 plus 88. That should give us 164. And then for our liability naman, no, for our liability for our payment. So for the first payment of 80K is worth 93 on year 5. So plus A. So A plus this one. Since we want to solve for A, we can now simply deduct this value from this value. That should give us 71,022.95 as our final payment on year 5. Last example. Jack owes 50,000 due in 2 years and 100,000 with interest of 16% compounded quarterly due in 3 years. So how much does he owe? 2 years and 3 years. So that's 50,000 and... Okay, sige. So if money is worth 18,000 compounded semi-annually, what single payment 7 years hence will be equivalent to the 2 original obligations? Okay, so this one is kind of tricky because so far we have been dealing with notes na non-interest bearing, or we have been dealing with liabilities na given na ilahang maturity value. But on this case, for liability 1, which is 50,000, is already given that the amount due is 50,000 in 2 years. However, for liability 2, what is given is only the face value, which is 100,000, and it is interest bearing. So meaning, what we should pay 3 years from now is actually 100,000 plus the additional interest of the 16% compounded quarterly for 3 years. So first, no problem in the 50,000 na non-interest bearing or given a maturity value. However, for the second example, we first have to solve for the maturity value or the compound amount of this liability 3 years from now. So at year 0, the value is 100,000. 3 years from now, the compounded amount should be at 100,000 times 1 plus the original, yung interest-bearing component, 0.16 over 4, kay quarterly man. We raised that to 12 because 4 nga quarterly times 3 years. So 12 periods. Again, the present value or the principal or the face value, we multiply that by 1 plus item over m, or 0.16 over 4, we raise that to m times t, or 4 times 3. This should give us a maturity value of the liability at 161.03. After getting for that maturity value, no, we now have to solve that yun. How much is the total payment if the liabilities will be paid 7 years from now? So, so in the future sa tanan, no, because our liabilities will mature on years 2 and 3. So for liability A, the 50,000 easy kay similar sa itong mga cases above. So we have to go forward. So that's 50,000. We multiply that by 1 plus 0.18 over 2. Sa amin annual naman siya. We raise that to 2 times 5. Okay? We have to go forward 5 years multiplied by the semi-annual compounding period. So that should give us an equivalent value of 118,000. While for our liability B, or second liability, what do you call this one? We only have to go forward by 4 years. So 7 minus 4, that's 4 years of going forward. And we will not be using the 100,000. We will be using the maturity value of 160,000 we have computed earlier. So that should give us this one. So 160 multiplied by 1 plus 0.18 over 2, or 0.09, raised to the power of 2, since semi-annual multiplied by the number of years we went forward. So that's 4 years. So that should give us an equivalent value of 319,000, and a total, since we will be paying these two obligations using just one payment. So that means that our payment now will be just the sum of the equivalent values of the first two liabilities, which is this one plus this one. That should give you 437,383.88. So we're done with this unit, and I hope that you have learned something today. Please, tawag nito, take note of our possible of the postings of your assignments for these chapters, Unit 2 and Unit 3, compound amount and present value. Also, please prepare for your unit drill, which could be given either Wednesday, Thursday, or Friday next week. Okay, so thank you again for listening, and I hope that you have learned something today. Have a great day.